All right, let's dive in. Today, we're taking a deep dive into something that's super important, especially if you're aiming for those senior software engineer roles.
Yeah.
It's all about really understanding the systems and the data structures behind data-heavy operations. So think of this as like targeted prep for those technical interviews where they really want to dig deep.
Right.
You know, getting a good grasp on how organizations handle and actually use these massive amounts of data they have.
Yeah, absolutely.
So we're going to be exploring the core ideas of data warehousing, like how's the data organized, how is it processed, and how do you actually use it to make smart decisions for a business.
That's it.
Our goal here is to really draw a line between the systems that are built for those everyday transactions that are happening all the time versus the systems that help you analyze trends, get insights, and make those strategic decisions.
Exactly.
And understanding that difference, and how a data warehouse bridges that gap, that's key.
Yeah, it's really important.
Okay, so let's get into it. One of the most fundamental things to understand is that not all data systems are the same.
Yeah.
We've got two main categories we talk about, OLTP and OLAP, online transaction processing, and online analytical processing.
That's right.
So think of it this way.
Okay.
OLTP is like handling the live day-to-day stuff of a business.
Yeah, the operations.
And OLAP is about stepping back, analyzing the big picture.
Exactly.
Spotting those trends and informing your strategy
Yeah.
to kind of illustrate how OLTP works in action. Let's imagine a few common scenarios.
Okay.
So you've got a customer buying something on an e-commerce site.
Yeah, very common.
You've got a worker in a warehouse managing inventory levels with an app on their phone.
Right.
Or you've got a delivery driver using a navigation system to figure out their route.
All the time, yeah.
Each of those people is interacting with a very specific OLTP system.
That's right.
It could be an online store, an
Yeah.
inventory management platform, or like a routing app. And behind each of those systems, there's a database, right?
Yeah, there is.
So the online store has, say, a sales database.
Okay.
The inventory app, maybe an inventory database. And the route planner would be using something like a geo database.
Right. Makes sense.
And these databases, they're capturing really specific, immediate transactional data.
Yeah.
So we're talking individual sales orders, current product quantities, specific delivery routes.
Absolutely. It's all about that immediate snapshot of what's happening.
And I guess the key thing to remember about these OLTP systems is their main purpose. They need to be fast.
Right. Speed is critical.
Like super fast. They've got to process individual transactions with practically no delay.
You got it.
Like when you add something to your online cart, you expect to see that change instantly.
Exactly.
That's that low latency. That's a hallmark of OLTP systems.
Precisely.
Okay, so we've talked about OLTP. Now let's switch gears a bit and talk about OLT. So here, we're moving away from processing individual transactions,
Right.
and we're looking at analyzing huge volumes of data.
Yeah, the big picture stuff.
Like what kind of questions would an OLAP system help answer?
So imagine a business analyst. They're trying to figure out the total revenue from each store over the last few months.
Yeah.
Or maybe they want to see how much banana sales jumped during a promotion.
Interesting.
Or perhaps they're looking at like what's often bought together, like baby food and diapers.
Got it.
These are the kinds of complex analytical questions that OLAD systems are designed for.
Right, they're built to handle that efficiently.
Exactly.
So the way you actually use these systems is pretty different, right?
Yeah, definitely.
With OLTP, it's lots of quick reads and writes all the time.
Very transactional.
But OLAP is about scanning massive data sets, doing complicated calculations, and spotting those patterns.
Precisely.
And the people who use them are different too, right?
Yeah, for sure.
OLTP is for your customers, your warehouse workers, delivery drivers, people involved in those daily operations.
Yep, the folks on the front lines.
But OLAP is more for the analysts, the decision makers.
Right.
They're the ones digging into the data to figure out strategy and make big decisions.
Exactly.
And the data itself reflects that, right?
Yeah, absolutely.
OLTP is all about the current state of things, like what's in stock right now, what orders are in progress, that kind of thing.
Yeah, up to the minute stuff.
But OLAP is dealing with historical records. It's capturing data over time so you can analyze trends and recognize patterns.
Exactly. Looking back to understand the present and the future.
And as you might imagine, the amount of data involved is totally different.
Oh, yeah.
An OLTP database might be gigabytes or terabytes.
Right.
But an OLAP system, especially a data warehouse, can be terabytes or even petabytes.
Yeah, it's often Huge.
It's combining info from so many sources.
All those different systems feeding into it.
So it sounds like companies realized pretty quickly that running those big analytical queries directly on their OLTP systems wasn't going to work.
Yeah, that was a big problem.
I mean, those OLAP queries need to look at so much data.
They can be really demanding.
And if you're doing that on the same system that's handling real-time transactions...
Right, like customer
just
order.
kill performance.
Yeah, it would bring everything to a crawl.
So imagine trying to run complex sales analysis on the same database that's processing new orders during Black Friday, for example.
Oh, it would be a disaster.
It would just grind everything to a halt.
Exactly, just wouldn't be sustainable.
So they needed a different solution, right?
Definitely.
They had to create a separate, dedicated database environment that was specifically optimized for these analytical workloads.
Right.
And that's where the data warehouse comes in.
Exactly.
It's like having a specialized research library.
Yeah, a separate space just for deep analysis.
Separate from where all the day-to-day records are kept.
It's a great analogy.
And the way you get data from all those different OLTP systems into this central data warehouse,
Yeah.
that's called ETL, right?
That's right. Extract, transform, load.
It's the pipeline that keeps the analytical engine running.
It's crucial for getting the data ready for analysis.
Okay, so let's break down that ETL process a bit more.
Sure.
That transformation stage seems like a really critical part.
Absolutely.
That's where raw data becomes useful information for analysis.
That's where the magic happens.
So first you've got the extract phase. That's pretty straightforward, right?
Yeah, relatively so.
You're selecting the relevant data from all those different OLTP databases.
You're pulling it all together.
Sales figures, inventory, customer details, logistics info, all of it.
Exactly.
Then you move on to transform.
Right.
And this is where you clean up the data and get it ready for analysis in the data warehouse.
You got to make sure it's consistent and reliable.
So what kind of transformations are we talking about here?
Well, think of it like prepping ingredients for a specific recipe. You've got all these different ingredients from different places, and you need to get them ready to work together. So first, there's cleaning.
Okay.
This involves handling any inconsistencies or errors in the data,
Right.
like correcting mistakes, filling in missing values if you can, and making sure everything's uniform.
So for example,
Yeah.
you might have customer contact information stored in different formats and different systems.
Exactly.
So cleaning would mean making all of that consistent.
Standardizing it.
So you have a reliable foundation for analysis.
Exactly. You can't build a good analysis on shaky data.
What other kinds of transformations happen?
So another important one is conversion.
Yeah.
This makes sure all the data types are compatible.
Right.
Like different databases might store dates in different ways or use different formats for numbers.
Yeah, that makes sense.
Conversion makes sure all of that is standardized in the data warehouse.
Okay, so everything's speaking the same language.
That's the idea.
Anything else?
Yeah, we've also got aggregation. This is where you take those raw data points and summarize them into something more meaningful.
So instead of having a million individual transactions, you might calculate daily or weekly sales totals or average delivery times.
That's right. You're creating key metrics.
And that reduces the amount of data that needs to be analyzed directly.
Exactly. It makes the analysis more manageable.
Makes sense. What else?
Then there's integration. This is about combining data from different sources to get a complete picture.
So you might link customer purchases from the sales database with their browsing history from the website.
Yeah, or with their social media activity or their interactions with customer support.
Wow, that's a lot of data.
It's all about getting a holistic view of the customer.
And finally,
we have data reduction. This involves using techniques to, slim down the data.
make it more manageable.
Yeah, while still keeping the most important info.
So you're optimizing storage and processing. Okay, so we've extracted the data, cleaned it, converted it, summarized it, and integrated it.
Phew, that's a lot of work.
What's the final step in this ETL pipeline?
Well, now it's time to load the data into the data warehouse.
Okay.
All that carefully transformed data gets loaded in, ready to be analyzed.
By analysts, by business intelligence tools.
That's right. It's ready to be put to use.
Now, once you've got all this data in the warehouse,
Yeah.
how do you structure it so that those complex analytical queries can run efficiently?
Right. That's a great question.
This is where the star schema comes in, right?
Exactly.
So tell me about the star schema.
Well, it's a really common and effective way to model data in a data warehouse.
Okay.
It's designed to be simple and to make queries run really fast.
Because speed is always important.
Yeah, especially when you're dealing with huge data sets.
So how does it work?
Picture a star shape.
Okay, I can do that.
You've got a central point and then points radiating out from it.
Right, like a classic five-pointed star.
Ex-
And in the data warehouse, that central point is the fact table, right?
You got it.
What does that table do?
The fact table holds the measurable facts about the business events you're tracking.
Okay, the numbers, the quantities, the things you can measure.
That's right.
So in our grocery store example, the central fact table might be called fact sales.
That's a good name for it.
And each row in that table would be a single sales transaction,
Right.
often at the item level.
Yep. Each item sold would be a separate row.
Okay, and how does this fact table connect to the other tables in the star schema?
So it's connected through foreign keys.
Okay, what are those?
They're basically pointers.
Okay.
They point to specific records in other tables that give you more context about the fact.
So in our fact sales example, you might have foreign keys like date key,
Right.
products, stores, promotions, customers.
Exactly.
And each of those keys links back to another table that has more details about that part of the sales transaction. So for instance, the products key would link to a table called dim products.
That's right.
What would be in that table?
So dim product would have all the details about each product,
Okay.
like its unique ID, which is the products, the SKU, a description, the brand name, what category it belongs to, things like that.
So it's everything about the product itself.
Yeah, all the descriptive attributes.
And the fact table itself has the actual metrics we want to analyze.
Right, the things we can count and measure.
Like the quantity of items sold, the net price, maybe the discount price.
Exactly.
And these are called the measures or the facts.
Yep, that's what we're analyzing.
And it's important to think about the granularity of the fact table.
Right, how detailed it is.
So in our sales example, it's at the line item level.
Yeah.
Meaning each row is a specific product sold within a transaction.
Very granular.
And that lets you do really detailed analysis later on.
You can slice and dice the data in all sorts of ways.
And these measures, they're usually additive, right?
Yeah, that's a key point.
Meaning you can add them up across different dimensions.
Exactly.
So you can calculate things like total sales for a specific product category or for a region.
It makes the analysis much more powerful.
Makes sense.
Yeah.
So we've got the central fact table with all the measurements. Now let's talk about the dimension tables.
Okay.
What kind of information do they typically have?
So the dimension tables provide all the context.
Okay.
They tell you the who, what, where, when, why, and how of the facts in the fact table.
So it's all the details surrounding the sale.
Yeah, they paint the complete picture.
We talked about dim product already.
Right, that's one of them.
And you'd also have a dim store table with info about each store location.
Like the store ID, the state, the city.
Right, so you can analyze sales by location.
Exactly.
And the when part of the sale would be in the dim date table.
You got it.
What would be in there?
So dim date would have the date key.
Okay.
And then a bunch of attributes related to that date.
Like the year, the month, the day.
Yep. And the day of the week, whether it was a holiday, things like that.
So you can see how sales differ on weekdays versus weekends or during holidays.
Exactly.
That's super useful for analyzing trends over time.
It gives you a lot of flexibility in your analysis.
And what about the who and the why of the sales?
Right. So for the who, you might have a dim customer table
Okay.
with the customer ID, their name, maybe their birthday, stuff like that.
So you can understand who's buying what.
Exactly. And segment your customers based on different characteristics.
And the why, would it be captured in a dim promotion table?
That's right.
What would be in there?
So dim promotion would have info about any promotions that we're running.
Like coupons, discounts, things like that.
Exactly.
You can see how different promotions affect sales.
Precisely.
And by linking all these tables to the fact sales table, you can analyze sales based on so many factors.
Right.
The products, the location, the time, the customer, even the promotions.
It's really powerful.
You get a very granular view of your business.
Yeah, and that's what makes the star schema so effective.
And this structure with the central fact table and the dimension tables around it,
Yeah,
it's got several advantages, right?
definitely.
That's pretty easy to understand.
Yeah, it's a very intuitive model.
You don't have to be a data scientist to get it.
Exactly.
And because it's so straightforward, queries that join those tables tend to be really fast.
They are. It's designed for performance.
So it's optimized for analysis.
You got it.
You mentioned that the dimension tables are denormalized.
Yeah.
What does that mean?
It means we intentionally add some redundancy to the dimension tables.
Okay, why would you do that?
It's all about speed.
Okay.
If you have all the information you need directly in the dimension tables, you don't have to do as many calculations when you're querying the data.
So it speeds things up.
Exactly.
So for example, in
Yeah.
the dim date table, having separate columns for year, month, and day,
Right.
that's denormalization.
Yep.
Because technically you could figure that out from just the date key. But having those columns separately makes queries faster.
It avoids unnecessary calculations.
So it's a trade-off.
Yeah.
You're sacrificing a bit of storage space to get better performance.
Exactly. And in data warehousing, performance is often king.
Makes sense. Anything else about star schemas?
Yeah. Another advantage is that they're very business-oriented.
Okay.
Those dimension tables represent real things in the business. Products, stores, customers, promotions.
So it's easy for business users to understand the data model.
Exactly. It makes sense to them.
And this structure also sets you up for more advanced analysis later on,
Right.
like building OLAP cubes.
Yep, those are built on top of star schemas.
Okay, so it's a foundation for more complex analysis.
Precise.
Can you give me an example of how a typical query would use this star schema structure?
Sure. Let's say you want to know the total sales of bananas in Seattle during January 2014.
Okay, a specific question.
Yeah.
How would you do that?
Well, you'd start by joining the fact sales table with the dim product table,
Okay.
and you'd filter it down to only include bananas.
Right, based on the description.
Exactly.
Then what?
Then you'd join that with the dim store table and filter it to only include sales from Seattle.
Based on the city attribute?
You got it.
And finally,
You join that with the dim day table
Okay.
and filter it to only include January 2014.
based on the year and month.
Precisely.
So now you've got all the sales of bananas in Seattle in January 2014.
Yeah.
And then what?
And you just add up the net price from all those rows.
And that gives you the total sales.
Exactly.
So you're using those joins and filters to get the specific data you need.
And the structure of the star schema makes that really efficient.
That's great. It really clarifies how it all works together.
Yeah, it's a powerful system.
You briefly mentioned a Snowflake schema before.
Yeah, I did.
How's that different from a star schema?
So Snowflake schema is kind of like a more normalized version of a star schema.
Okay, so more organized in a way.
Yeah, you could say that.
How does it work?
So in a Snowflake schema, those dimension tables are broken down even further.
Okay.
You have more tables, and they're more closely linked.
So instead of having brand and category in the dim product table,
Right.
you might have separate tables for those.
Exactly. A dim brand table and a dim category table.
And then dim product would link to those.
Precisely.
Okay, so why would you do that?
Well, it reduces redundancy.
Okay.
You're not storing the same information in multiple places.
So it's more efficient in terms of storage?
Yeah. But it can also make queries a bit slower
Why is that?
because now you have to do more joins to get the data you need.
Okay, so there's a trade-off there.
Yeah, always a trade-off.
So star schemas are often preferred because they're simpler and faster.
Yeah, they're a good balance of performance and complexity.
Makes sense.
Yeah.
Okay, so let's wrap up our deep dive today.
That was good.
We've explored the key differences between OLTP systems,
Mm-hmm.
which are all about speed and handling those real-time transactions.
Right. The operational side of things.
And OLAP systems, which are designed for deep analysis of historical data.
Exactly. The analytical side.
And understanding when to use each is really important.
Absolutely. They serve different purposes.
We talked about how OLTP systems keep the business running smoothly.
Yeah, they handle the day-to-day stuff.
And they use databases that reflect the current state of affairs,
The here and now?
while OLA systems are built for those complex queries.
Yeah, the ones that look at huge amounts of data.
And they often rely on a central data warehouse.
Right, where all the historical data is stored.
And we looked at the ETL process,
Mm-hmm.
which moves and prepares data from those operational OLTP systems into the data warehouse.
Getting it ready for analysis.
And that involves important steps like cleaning, conversion, aggregation, and integration.
All those transformations are crucial.
And finally, we delved into the star schema.
Yeah, one of the most common data modeling techniques.
It's got that central fact table with the measurements.
And the foreign keys linking it to the dimension table.
Yes, and those dimension tables provide all the context.
The who, what, where, when, and why.
It's all designed for simplicity and efficiency.
Easy to understand, fast to query.
So for anyone prepping for those tough tech interviews, especially for senior roles,
Yeah,
understanding these data warehousing concepts is so valuable.
it really is.
It shows you understand how data is managed, processed, and analyzed at scale.
Which is crucial for any senior engineer.
And as you're preparing,
Yeah,
think about how these concepts connect to the bigger picture of system design.
right. And performance optimization.
Being able to discuss those trade-offs between transactional and analytical systems.
And how data is structured and moved to meet those needs.
That shows a really deep understanding of data architecture.
It's a great way to impress your interviewers.
That's a fantastic point to end on.
Yeah, I think so too.
Thanks for joining us for this deep dive into data warehousing.
It was my pleasure.
And we'll see you next time on the Deep Dive.